Okay, so for this first question, if I remember right, we wanted to find what the period was for the balloon, and we wanted to see, just demonstrate simple harmonic motion. So first we have our knowns, the density of the length and the density of the air. I think this was the density of the helium. Anyhow, so we have our arc and our theta and our length. We put all that information into our equation, just following the simplification of it, so that we end up with this equation: V equals negative the density of the air times the velocity of gravity minus the density of helium times the velocity of gravity divided by the length. And then we use our simple harmonic equation, F equals negative k times x. Then we insert, or insert is not the right word, but substitute that information into our equation, which ends up being V equals the density of air times this. Anyway, everything that I just said. And we see that if we compare it to our K equation, that this is the equation for simple harmonic motion, that they're very similar. And so we can show that this is a simple harmonic motion. And then to find its period, we take period equals 2 pi times the square root of m over k, insert the information that we have, do the math, we end up with 1.399 seconds for the period. For number 2, we want to find out how far to stay away from a speaker so that we don't get ear damage or hearing damage. We know that 30 seconds at 115 decibels equals damage. 1 hour at 94 decibels also equals damage. We want to be below 94 decibels. We know that the speaker produces 41 watts. We're going to use this equation, I equals P over 4 pi r squared, which when we rearrange it, we get r equals P over 4 pi I, and take the square root, insert the information we have, 41 watts divided by 4 pi times 94 decibels is what we're, that's our base point, and we see that we have to stay at least 0.1814 meters away from the speaker. And then for number 3, we are trying to find the percentage change in the tension of the string. So we take our equation of C equals, if I can read my own handwriting, 1 over 2L times the square root of tension over mass. This part of the equation ends up not really mattering that much because it ends up canceling out. So we take our hertz, find the difference in that, and then like I said, once we actually put it into the percentage, these two cancel, we end up with 58.7% change, and that's the answer.